Hi, it's Callum. So this marks the end of our GI series. I'm going to finish by talking about a large bowel. So this is the same section that I used to describe the layers of the GI tract. So I won't labour that point, but I'll just go over it quickly. So this is the luminal aspect. This here is the mucosa. Underlying that, we've got submucosa, then muscularis propria, and below that adventitia or subserosa. So really I'm going to focus on the mucosa here, because that is, first of all, the source of the majority of the pathology within the large bowel. Secondly, because a lot of the times you will encounter large bowel is within biopsy specimens taken at the time of colonoscopy, where you will only be looking at superficial fragments from the mucosa. So we just looked at the small bowel, and there's a couple of differences here between when we look at large bowel versus small bowel. First of all, the surface here is quite flat. We haven't got the villi, and that reflects the fact that although the small bowel's main purpose is absorptive, within the large bowel there's not really all that much absorption happening. The large bowel does have some absorptive capacity, but mainly it's for water or for some salts. Most of the absorption's already happened by this stage. So if we look at the surface, this is the surface epithelium, and a lot of that is, these are the absorptive cells, these basally located nuclei with eosinophilic cytoplasm, and you can see the brush border here at the surface, the little hair-like projections of absorptive cells. So these are the absorptive cells of the enterocytes of the large bowel. Underlying that, you can see this is the crypt architecture of the large bowel. It doesn't have the villi, but it does have the crypts, and these crypts are said to be like test tubes in a rack. You've got crypt here, all lining up next to each other, like test tubes in a rack. That's what it looks like when you see a normal longitudinal section. If you see them on transverse section, they look a bit like this. So if you imagine, if you took a section through this crypt like that, it might look a bit like this. So you'll probably have already noticed that the cells that line these crypts are a wee bit different from most of the cells here, the absorptive cells, in that they all have these big, clear circles within them. That's because these are full of mucin, and these are goblet cells. So similar to the goblet cells that you saw in the small intestine, but they're much more numerous within the large intestine than the large bowel. And so that forms the majority of the cells, the absorptive enterocytes and the goblet cells. But there are, if we look at, and at the base of the crypts, there'll be stem cells which replicate and specialize to form the cells of the crypts and the surface. But they're also, if we look around, so we can see another type of cell. So this is a neuroendocrine cell, and I can tell that because the nucleus is up at, not basally located, not at this end, it's up at the luminal end, and underlying that there's this pink granular stuff. And these are the neuroendocrine secretory granules, and these are neuroendocrine cells. Now, if it was flipped around the other way, if the nucleus was at the bottom and the pink stuff was at the surface, at the luminal aspect, that would be a Paneth cell. I'm not seeing any Paneth cells here, and that's probably because this is not taken from the colon. Not taken from the cecum or ascending colon, where you expect to see Paneth cells. In the left colon, you don't expect to see Paneth cells. Paneth cells are, in fact, if you see them, that indicates that there's something wrong with that colon. So that's really the main cell types that you'll see. And between the cells, between the epithelial cells of the crypts, are the inflammatory cells of the lamina propria. Now, it's normal within the large bowel to have chronic inflammatory cells within the lamina propria. You will see a mixture of lymphocytes, of plasma cells, and occasional eosinophils, and that is normal. So let's see if we can identify some of them. So lymphocytes look like sort of like inky purple dots with hardly any cytoplasm. There's maybe an eosinophil. A lymphocyte. There's a lymphocyte. Inky purple dot, hardly any cytoplasm, and you'll see lymphocytes scattered around, and that's a normal finding. In addition to those, you also see eosinophils. So there's an eosinophil. Nucleus, these are bilobe nuclei, but you're only seeing one of the lobes here due to the plane of section, but that's okay. This is definitely an eosinophil. There's another one because it's got this bright pink granular eosinophilic cytoplasm. And so I know that's an eosinophil. So there's eosinophils. We've covered lymphocytes. And the third this main cell type is a plasma cell. So these are plasma cells. And the reason I know these are plasma cells is they've got nucleus off to one side, cytoplasm all to the other side. And the nucleus has got this clumped chromatin, which often gathers around the outside in what they call a clock face pattern. Looks like the face of a clock. This clumped chromatin that gathers around the outside, and we call that a clock face chromatin. So when you see cells with a clock face chromatin within the nucleus that's off to one side, the cytoplasm off to the other side, and often we'll see a perinuclear HOF, or just beside the nucleus there'll be a kind of lighter pink area called a perinuclear HOF. That's a plasma cell. So that's a plasma cell, that's a plasma cell, that's a plasma cell, and so on. And these are all plasma cells. There's quite a lot of them here, and that's because we're up near the luminal aspect. If we follow this down to the base, there's hardly any plasma cells. We'll be able to identify one or two. There's a couple. A few more here, but not many. Not nearly as many as there are up here. Loads up here, loads up here. And that's normal. That's called the plasma cell gradient. So there should be loads up here, hardly any down here. And that's the plasma cell gradient, and that's normal. If you see the loss of the plasma cell gradient, so plasma cells down here, well, the same number of plasma cells down here as there are up here, that's a basal plasmacytosis or loss of the plasma cell gradient. And that means that this bowel is chronically inflamed. But that's not what we've got here because this is normal. This is normal colon. But that's how you can tell if a colon is chronically inflamed. Something else that happens if over a long period of time in the colon, if it's chronically inflamed, is the crypts get damaged and they can start looking a bit abnormal. And they don't look like this kind of nice test tube rack appearance. Perhaps they might look bifid. So the crypt might come down here and then split off into two at the bottom. That's crypt bifurcation. That's abnormal. Or you might just lose crypts altogether. So there might just be a big gap where there was crypts. If you see that all over the place, those things together are known as crypt distortion. Also, if you see lots of Paneth cells where you're not expecting to see them, like in the left side of the colon, that's an indication of architectural distortion. And all of these things indicate chronic inflammation within the colon. It's been going on for a long time. If you see neutrophils or acute inflammatory cells, that is an indication of acute inflammation or active inflammation. And that's different. That's inflammation that's happening right now. Not necessarily that's been going on for a long time. And that's abnormal too. You should never see neutrophils under normal conditions within the colon. So that indicates active or acute inflammation if you see neutrophils. And you can see them within the lamina propria, or you can see them within the crypts themselves, and that's called cryptitis if the crypt themselves have neutrophils in them. Or you can see them within the lumen of the crypts, and that's called a crypt abscess. You see that if in here was just packed with neutrophils, that would be called a crypt abscess. And they all indicate varying degrees of acute inflammation. So that pretty much covers most of the normal architecture. You'll see lymphoid aggregates like we've got here, a lot of lymphoid cells here, which are a mixture of lymphocytes and plasma cells, and that's normal to see a few of them. Throughout the bowel, really, it will all look the same pretty much. Obviously, I've mentioned that there will be Paneth cells. You might see Paneth cells in the cecum or ascending colon, and also within the rectum. You might see a little bit of architectural distortion, occasional loss of a crypt, occasional bifid crypt, and that's okay as long as it's not too many. Otherwise, it will look identical. And basically, the appendix looks identical too, although it often has more lymphoid tissue, more lymphoid aggregates than you see within the large bowel. But otherwise, it looks pretty much identical. And that will pretty much cover everything within the GI tract that I was hoping to cover. the next series of videos I'm going to do is I'm going to cover the gynae tract. So hopefully I'll see you then, and you can join me for the continuation of this course where I'll be looking at the gynae tract. Okay, see you soon.